So the first question says to graph f of x equals 1/2 to the x power. So simply you're going to go to your y equals, and you are going to put that into your y equals. And then after you do that, you're going to go to table, and we're just going to get a table of values. So let's just start writing those table of values down. So let's just say I'm going to start looking at -3. And if you go to that table of values, you should see that the y value that corresponds with that is 8. And then -2 would be 4. -1 is 2. 0 is 1. And then let's do the positives of those numbers. So 1 is 1/2. +2 would be 1/4. And lastly, 3 would be 1/8. Okay, well, it's very simple. All we're going to do is we're going to plot points. So I'm going to go to -3, and then I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. Plot that point. Sorry if that's a little off. I'm doing the best I can. It's a small graph. And then we're going to go to -2, 1, 2, 3, 4. Then I'm going to go to -1, 2, 0, 1. All right, I'm going to really do the best I can here. But if you notice, what's happening here is we see that these numbers are getting smaller. Okay, this is the largest fraction. 1/2 is bigger than 1/4, which is obviously bigger than an 8. 1/8 rather. So these fractions, these y values, are getting smaller, so our graph should be decreasing then as we move along here. Okay, and I again apologize, it's not going to be pretty. So like there, and we're slowly getting lower there. Hey, not so bad, right? So what we're going to do is we're going to connect those dots. Now, here's the thing on the right-hand side here. If you were to go to your table and just scroll down to x values of 4, 5, 6, 7, 8, you'll see that the y values will never reach 0. So we call that, if you look down at number 1 below that, okay, so let's just look at this right here. It says, what is the equation of the asymptote to the graph of f of x? An asymptote is a line that a graph comes closer to, but never hits it. So if we look at this graph, you can see that this graph is getting closer and closer and closer and closer to the x-axis. But look, it never touches it. And you can see that by looking at the table in your calculator. So when they ask you what's the equation of the asymptote to the graph of f of x, we would say the x-axis. But the x-axis is not an equation of a line, so all of the y values on the x-axis equal 0, so the equation would be y equals 0. Okay, so again, and you can look in your notes there right above the question. All right, the next thing, if you look below, you will see that it asks for the domain and the range. Right down here, it says state the domain and the range. Okay, so domain are the x values and range are the y values. So let's look up at the graph. If you look at this graph here, do you see these x values keep going on forever and ever and ever and ever and ever to the right? Remember, that's called infinity. Now to the left, yes, this graph keeps going up, but you can also see that these x values keep getting lower and lower and lower. If we were to continue this graph on, it will continue in this direction. So therefore the x values are getting smaller as we move to the left. So if they ask us then what is the domain, we would say, I'm going to write it over here, the domain is from -infinity all the way up to +infinity. Now we call this interval notation. So what we do is we either put a square bracket like this, or we'll just put a parentheses like that. A square bracket means that it includes that value, but since -infinity goes on forever and ever, we can't include something that just keeps going. So around infinities, we tend to put parentheses. So there's our domain. Now let's look at the range. Range are your y values. So if you look at the range, and let's look at the y values here, do you see here that our lowest y value here would be 0, but actually it doesn't reach it, correct? So it's just above 0, because remember, this is an asymptote, the x-axis. So the graph never hits the x-axis. So we would be bigger than 0 and all the way up to infinity, because this graph keeps going up higher and higher and higher. Okay, so if we want to then write the range, we would say 0. Now we're not including 0, because remember, there's an asymptote at y equals 0, so we don't hit that value. And we go all the way up to infinity, and we never include infinity. So we do the same thing with this next question. So this one wants the graph of g of x. So again, go to your y equals, plug that in, go to your table, look at the table of values. All right, so I'm going to use the same x values. So this is 1/8, then this is 1/4, this is 1/2. You should be taking notes in your packet, by the way. That goes without saying, but, and all the way down to 8. All right, so we're going to do the same exact thing. So basically what we're going to do is we're going to plot these points. Now, if you notice here, this graph is a little bit different, because notice that the values here at the top of the y column, those are fractions, and as we get higher, these y values actually get lower. So the left side of our graph should be smaller. So this is so tiny, I apologize if I'm off, and I am already. Okay, and there's 0, 1, there's 1, 2, 2, 4, and 3, 1, let me see, 1, 2, 3, 4, 5, 6, 7, 8, there. So our graph, and again I apologize if it's not the most accurate, I'm doing the best I can, there we go. It's not too bad. There's my g of x. Okay, you can see that it kind of trails off here on the left-hand side. So if we're talking about an asymptote, do you see that the asymptote is still the x-axis, because the graph gets closer to it, but it doesn't hit it? So the x-axis would still be the asymptote. Okay, so if we look down at the bottom here, it's asking us what's the equation of the asymptote. We would still say it's y equals 0. All right, now let's look at the number 4 down here at the bottom. So they want the domain and the range. Well, the domain, let's look at the domain. The x values, we're still going all the way over to negative infinity over here. It's going to keep going to the left, to the left, to the left. And the same thing over here. Even though the graph does go up, this will also, it kind of scoots out to the right a little bit. So those x values are going to get higher each time. So we would still say that the domain is negative infinity to infinity. All right, and lastly, the range are the y values, and you can see that that's also the same. The lowest y value would be 0, but we don't touch it, so we put parentheses around it, and we go all the way up to infinity. Now, there's one last thing that I want to talk about, which I didn't talk about in the last graph, and I'd like to just take a minute and let's look at this. If you notice, if we, it's kind of like when we read from left to right. So if we look at this graph, and we start at the left, and we go to the right, do you see that my arrow keeps going higher and higher and higher? Okay, so going from left to right, do you see my graph goes up? So what we call that then, let me just get this for you, we call that an exponential growth. Growth because it gets higher. All right, now, if you look at the other one, and I'm just going to quickly sketch it because it'll just be a little bit easier. The other one, the f of x graph, looked like that, right? So if you look at that, look, going from left to the right, do you see that that's going down? And you're pretty smart. I'm sure you could figure out what that's called. All right, so this one is called an exponential decay. Okay, decay is something that declines, right? And so if you look at this, we are declining or getting lower as we go from left to right.